All right, welcome back. Hey, we're at our first unit for semester 2. So hopefully you guys passed the final exam, did well on that, and you're ready to go for second and last part of the year. Starting off with Unit 7, we are going to be talking about inequalities, solving and graphing inequalities. This first section, we're going to break down again what inequalities represent and also something called absolute value. So first of all, what is an inequality? Inequality, I guess just in general, inequality means things, in means not. So we're talking about things that are not equal. So we're comparing two quantities that are not the same. So there's different ways in which we can do this, just as a review, with some of the symbols. Some of the things we can hear is instead of two things being equal, we could say that one is less than the other. Along with that, we can do the opposite and say one is greater than. Then we have greater than or equal to, which you may also see as no more than, less than or equal to, which is no less than, and then lastly, not equal to each other would be just a basic thing about inequality, not being equal. Okay, so just remember these symbols. The way I want you to remember these, and what students struggle with is being able to determine the difference between, for example, less than and greater than. So remember, I always like to think about everyone's favorite, pizza. Okay, so imagine the inequality as a mouth, num-nums. Okay, the mouth always wants to eat. If you think pizza, you're always going to want to eat the bigger slice, because everyone knows that if you have a pizza and you have a little sliver piece like that, or you have a huge piece like that, everybody's going to want to eat this piece, right? So you always want to eat the bigger piece, so that means the mouth is always going to point towards the big, and the little arrowhead always going to point towards the small. Imagine eating pizza. We always want to eat the more big. I'll just say it doesn't make any sense. You're going to eat the more bigger slice. All right, so first of all, let's talk about how do we represent an inequality. So let's say we have our man Brust here. Say he's broke. He has less than $9 in his wallet. Okay, so he has less than $9. You think about what this means, less than $9. So less than, that's our inequality. So he has, could be $8, could be $7. We don't know an exact amount, but we know that it's not $9, and it's less than $9. So we're going to represent this as on a number line. You guys might have done this before. So we're going to start first with our number $9. This is going to represent our boundary. So we're going to place this right in the middle, and then we're just going to represent some quantities above and below. So I'm going to go 10, 11, and then 8 and 7. Okay, just choose two numbers above or below. And what I want to do is I want to represent on this number line anything that would be less than $9. So you could have $8, $7, $6, so on and so on. You could even be missing money and have negative $2, like you are $2 in debt or something. So what we're going to represent this is our boundary is 9. Okay, so we're going to put a dot at 9. Okay, now what we're going to figure out with this boundary, we're going to talk about two things. Is the value of 9 included? Is $9 included in this idea of less than? Well, if you think about it, no, $9 is not included. $9 is $9, but we need to include even $8.99. That is technically less than $9. So we want to include every value less than 9 except for 9. So the way we're going to represent that is we're going to use an open dot at 9, and then we're going to use an arrow and point that arrow to the left. Basically saying 9 is my boundary. I'm not including it, but I am including everything to the left of 9, everything that would be less than. All right, next one we have Kelly has no less than $5 in his wallet. So again, to set this up, we're going to do the same thing. I'm going to place my boundary of $5 in the middle. I'm going to choose two values above, so let's go 6 and 7. Two values below, 4 and 3. Okay, my boundary is $5, so that means I'm going to place my dot at $5. I'm just placing it above so you guys can see. You can place it directly on the number line if you want. So if you want to write it there, that's perfectly fine. But here the inequality says no less than $5. So here's what you got to think about. Is $5 included? So no less than means that you cannot have anything less than $5. But $5 is included. So the way we're going to represent that first is by closing the dot at 5. We're basically saying 5 is a part of this. It's included. But we want no less than. So I don't want anything less than $5. I only want things more than $5. So what numbers are more than 5? Well, 6 more than 5? Yeah. 7, 8, 9, continues on forever. Anything that's greater than 5 would fit that inequality. So that means we're going to put an arrow to the right. So notice the arrowhead is representing what values would fit the inequality. The difference here about them being not equal is because if I say you don't have $2, well, that really could mean a lot. You could have $5, you could have $1, as long as you don't have $2. So it gets a little tricky because we have a lot of things. And that goes into our last one. It says here Sully does not have $8. Well, again, our boundary is going to be $8, so I'm going to put that in the middle. I'm going to choose just some values above, so 9 and 10, and some values below, so 7 and 6. And I want to think about he does not have $8. So again, our boundary is going to be at 8, so we're going to put a dot there. Is 8 included? Do I open it or close it? Okay, so 8 is not included because he does not have it. But if he doesn't have $8, would $9 fit? Yeah, $9 is not $8. Okay, so it could be the numbers above. Now this one says it also does not have $8. Well, what about $7? What about numbers below this value? Well, notice $7 is not $8. So if you think about it, that also fits the picture. Okay, so that one, we're going to have the arrow going both directions. But the only thing we are not including is the value of 8. Okay, so going through this, notice that when we're graphing it again, you're going to think about your boundary. You're going to think about what values fit the inequality. But the one tricky part is when do we have an open dot and when do we have a closed dot. So notice the open dot was with things like less than, greater than, not equal to. Okay, those are things when we had an open dot because we're not including that value. But when I get to the value of less than or equal to, greater than or equal to, or simply equal to, those ones we are going to represent with a closed dot. So closed dot there, open dot there. Okay, so that's one thing you're going to have to distinguish because when we think about these ones, we are including the values, less than or equal to. The or means that that value is included. Okay, very good. So let's go into more practice. The first one we have x is greater than -7. So this one we're told the inequality. So again, we're going to start with our boundary of -7. Put that in the middle. And let's choose two values above and below. Now, careful here. You want two values bigger than -7. Okay? So what numbers would be bigger than -7? Some of you might want to put -8 and -9. That's incorrect. Remember, negatives, when you get less negative, that actually means you have more. So we're going to put -6, -5, and -8 and -9. It's a big mistake, so make sure if you did that, you correct it. Okay, then I want to know x is greater than -7, so I'm going to start with my dot at -7. Am I going to include it? Well, the inequality is less than, not equal to, so it can't be included. So, sorry, not less than, that's greater than, sorry. That's greater than, said that wrong. So I want to know what numbers are greater than -7. Well, you may think, oh, 8's bigger, 9's bigger. Well, no, these are more negative. That means you actually have less. So this case, bigger is going to point that direction. Okay? So not including, and my arrow is going to go to the right. Next one, let's go down below. We got g is less than or equal to 14. Again, start with your boundary of 14. Choose some values above or below. Since this is positive, should be easy. We have 15, 16 there, and 13 and 12 on the other side. I'm going to put my boundary or my dot at 14. Now I want to know, is 14 included? Well, the inequality is less than or equal to. So the or equal to means I'm going to close the dot. 14 is included, and I also want to include anything that's less than 14, meaning my arrow is going to go to the left because I'm going to include all those values that are less than 14. All right, now, notice how all of these, my variable and my inequality is always from left to right. So what if I flip it on you and say, in this case, -7 is less than x? Okay? This one, I want you to be able to read this as is. So again, we're still going to start with our -7. That's going to be our boundary. We're going to set it up the same way. I still want two numbers bigger, so -6 and -5, and -8 and -9. Now, notice the inequality says -7 is less than x. So I want you to think about that, say it to yourself, and what does that tell you in terms of x? So my boundary's at -7. I'm going to leave it open again because our inequality is less than. But it says -7 is less than x. So what does that tell you about x? Well, if -7 is less than or smaller than x, that means x must be greater than -7. So my arrow is going to go to the right. Okay, now is that any different than over here? No, it isn't. Notice it's the same thing. X is greater than negative 7 is the same thing as negative 7 is less than x. They describe the same thing, just using the other inequality. What might help is to be able to rewrite this. Okay, notice how the opening here faces x, so if I want to write this with x first, I got to keep the inequality the same. So the mouth points towards x. I'm going to keep the mouth pointing towards x and just flip the two things. Okay, basically everything flips. So I would say x is greater than negative 7, which is the same thing we have here. Okay, so this one, I have 14 is greater than or equal to g. This would be the same thing as saying g is, and I'm going to flip the sign here. Notice how it's pointing to the right. I'm going to flip it and point it to the left and do that. Now this says g is less than or equal to 14, and is that any different than what we did in this example here? No. So this graph will look the same thing there, so I'm just not going to graph it. And the last one we have h is not equal to negative 8. So remember this is not equal, so I'm going to go negative 8 here. Choose two values above and below. What would be my two values above negative 8? Hopefully you're thinking negative 7 and negative 6. And this will be negative 9 and negative 10. Those are values greater and less than. I'm going to put my open dot at negative 8. I'm not including negative 8, but I want to include every other value because it's not equal to 8. So I'm going to choose any value above and any value below, but the opening at 8, or negative 8, I'm sorry, is telling me that this is not included. All right, now let's flip it. Now let me give you the number line, and let's see if we can figure out what the inequality is. So we know, let's just use the value of x as our variable. We know our boundary is at 2. So now I want to just think about what values are included and not included. So notice here, if this is 2, I have 1, 0, negative 1, negative 2, negative 3. So I'm including all the values smaller than 2. So what does that tell me about x? X must be less than 2. So be able to write the inequality from a graph. Okay? Now remember, less than, I have to use that because it's an open dot. Next one, I have a closed dot. So I know that we're going to be have to include the equal sign. Okay, so what do we have here? Well, negative 2. I know that my boundary is negative 2. And look at all the values. I'm going all the values bigger than negative 2. So x must be greater than, but because the dot is closed, we're including negative 2. We must add the equal sign. So x is greater than or equal to negative 2. Very good. All right, next thing, which we also want to represent on a number line, something we did talk about early in the year, is a absolute value. Okay, so the absolute value symbol, if you remember, is the two vertical bars that surround a number. So like we have in the examples below, the absolute value of 5. What does the absolute value mean? The absolute value simply describes the distance that number is from 0 on a number line. Okay, so take for example the absolute value of 5. Okay, 5 on a number line is all the way over here. Okay, 0, let me mark this in green, is right here. I want to know how far away is 5 from 0. So all I have to do to figure this out is count. I got to go 1, 2, 3, 4, 5. So how far away is 5 from 0? It is 5. So it's 5 units away. So the absolute value of 5 is 5. Okay, it's kind of easy. It makes it positive. So let's say about negative 3. Negative 3, where's that on the number line? That is right here. So the absolute value describes how far away it is from 0. So how far away is negative 3 from 0? Well, let's start from negative 3 and just count. 1, 2, 3. So it is 3 units away. So that means the absolute value of negative 3 is 3. Now you may be saying, does it matter which way I count? Does it matter if I go here versus here? This way I counted left, this way I counted right. Well, no, it doesn't matter. Think about when you're driving on the road. Okay, if you go, let's say, I don't know, here is Milwaukee. Okay, and let's say you're north of Milwaukee versus south of Milwaukee. Here you're going to see a sign coming into Milwaukee says 25 miles to Milwaukee. Over here, is it going to say negative 25 miles to Milwaukee? No, it's going to say positive 25 and positive 25. Because no matter what, the distance from there to Milwaukee is going to be the same. So when we talk about distance, it's easy because we don't talk about a negative distance. So that's kind of the nice thing about absolute values. It kind of trips students up, but the absolute value is always going to be positive. Okay? okay? So think about this, a little analogy. Think about washing machine, okay? Some of you might like this, okay? Negative numbers. Nobody likes negative numbers, so imagine negative numbers are dirty clothes. When you throw dirty clothes into a washing machine, what happens? They get clean, right? They come out clean, they come out positive. When you put clean clothes even in a wash machine, guess what? They still come out clean. You don't put clean clothes into a wash machine and they get dirty. Otherwise, your washing machine stinks. You know what I'm saying? So, think of these absolute value bars as a wash machine. Always is going to give you a positive number. Simple as it is to understand, that's a big mistake that a lot of students will make with absolute values. So let's go through some examples. First one I have, what is the absolute value of negative 0.5? So again, I see the vertical bars. I know I'm asking for or absolute value. Okay, I want to know simply how far is 0.5 away, or negative 0.5 away from 0? Well, it is 0.5 units away. Don't get confused. I like to write 0.5, so don't get confused there. But again, it's positive. You put that dirty laundry in, it's going to be clean. Okay? This one, absolute value of positive 1/2. Okay, how far is 1/2 away from 0? Well, it's 1/2 units away from 0. So it's the same thing. Okay? Just because it's positive doesn't mean it changes to a negative. Put clean clothes into a wash machine, they're still going to come out clean. Same thing here. Absolute value of 126. How far away is 126 from 0? It's 126 units away. Again, doesn't matter if it's positive, clean clothes will come out clean. Now again, we have dirty clothes. We got a negative symbol. How far away is negative 3/4 away from 0? It's 3/4 unit away. Positive 3/4 distance we only describe as a positive. Okay, so notice absolute values are kind of easy once you get the hang of them. All right, now I want you to think about these. What if I asked you to solve for x? So let's say I said the absolute value of x is 5. So this unknown number, the absolute value of what? What number would give you 5? Well, I'm simply asking you, if this is 0 on a number line, what number is 5 units away? So here's how you can figure this out. Okay, it's pretty simple. I'm going to start from 0, and I'm going to go 5 units in both directions. 1, 2, 3, 4, 5. Okay, so that means it could be 5. What about the other direction? 1, 2, 3, 4, 5. Oh! Or it could be negative 5. So here I get 2 possible answers. X could be 5 or X could be negative 5. I'm basically saying the absolute value of 5 is 5 and the absolute value of negative 5 is 5. They're both 5 units away from 0. Okay, same thing here. What do you think about 4? Well, let's use a different color. Use our number line again. If I start from 0, I'm going to start here right in the middle. I'll start from 0. Let's go 4 in either direction. 1, 2, 3, 4. So it could be 4. Or, I'm going to go 4 in the other direction, it could be negative 4. Kind of getting the hang of it? All right, now, what about negative 3? The absolute value of what could give me negative 3? Well, let's think about this. What if that was 3? Okay, well, the absolute value of 3 would be negative. Could this have... Time out for a second. Remember, whatever's inside the absolute value bars tells me how far away it is from 0. Is it ever possible to get a negative answer? And this is no. So in this case, this means no solution. There is no way an absolute value will give you a negative number. There's no way you put clothes into a washing machine and you get dirtier clothes. Okay? Otherwise, the washing machine's broke. And tell you what, absolute values are not going to break, brothers and sisters, because it is what it is. You know what I'm saying? So in this case, if you ever see the absolute value of a number giving you a negative, right away, no solution. All right, so right now I want you to pause the video, give it a good pause. I got 3 problems here. The first one's like our first set of examples. I want you to translate what is said in the problem and graph it. Number 2, I want you to graph. And then number 3, like the examples we just did, I want you to solve. So go ahead, give this a nice, good old pause, and we'll talk about the solutions in just a second. Here we go. All right, let's take a look at hopefully what you got. Now the first one, don't get confused. It says Brust and Kelly have no more than 12 kids combined. So Brust and Kelly have considered them together, B and K, looking at their total kids. So another way you can think about this is you can just think of the number of kids that they have has to be less than or equal to 12. Key thing, how did I get less than or equal to? I thought no more than. They cannot have any more than 12 kids. Okay, so that's why any more than or no more, I'm thinking less than. And remember with these ones, we're also going to include the equal because it is possible to have 12 kids. So graphing this, what I then did is placed my 12, my boundary in the middle. Then I looked at two numbers above and below, and I think, okay, no more than, that means anything less than 12 is okay. And because of the equal sign, 12 is also included. So I did my closed dot and arrow to the left. Next one, it says -5 is greater than y. So again, I like to read this left to right like a book. So I did y and I flipped it. I kept the sign. Notice how the arrow points towards y. So when I flip it, I got to maintain the same thing. And then -5. So I have y is less than -5. Okay, so now graphing this, I placed my boundary -5. My numbers above and below, again, -4 and -3 should actually go to the right here. Okay, don't get confused by the negatives. And then I had the open dot because 5 is not included, and any value less than would be -6, -7, beyond. So arrow to the left. And then lastly, solve. Absolute value of x equals 8. So what number, when I take the absolute value of it, would give me 8? Basically saying what number is 8 units away on a number line. Okay, so you could graph it. I didn't need to. What I thought about, okay, is the absolute value of 8 is 8. That means 8 is 8 units away from 0, and -8 is also 8 units away from 0. So the two answers I get would be 8 and -8. All right, so this is just kind of a brief run-through on inequalities, how to graph them, how to understand them, translate them, and then also absolute values. Good luck on your practice problems. Make sure you bring any questions to class, and we'll see you guys later. Adios.